Next up in this land use under drawdown is tropical forests. We already mentioned that most of the deforestation and even the coastal wetland disturbances and losses are happening in the tropics. So the ranking here, if we can protect the rainforests, the tropical forests, is at number 5, so very high, with 61.23 gigatons in reduced CO2. Again, global cost and saving data are too variable, so they are not reported here. This is a sad picture. Burning continues to be the preferred means of clearing land in the Amazon to make way for cattle. It's a delusional act because the thin acid soils quickly degrade and fail. This picture was taken in Rondonia state, just northeast of Bolivia. So the forest fires and so on, as I mentioned in the previous podcast, have made the disturbances, reclamations for agriculture, grazing and timber and so on, have made Amazon now a net emitter of carbon, which is rather scary. This forest, Monteverde Cloud Forest Reserve in Costa Rica, comprises 26,000 acres of virgin forest, possibly containing the most diverse biome in the world. It was named by Quaker farmers who moved from Alabama to Costa Rica to avoid being drafted for the Korean War. So they called it the Cloud Forest. Costa Rica had just abolished its armies, which was the driver for choosing Costa Rica by these Quaker farmers who are peaceful and they don't believe in wars. It was Green Mountain to them. Monteverde, ever since the name Monteverde, it means Green Mountain. Just to touch again on some of the statistics numbers we saw before, this is the map of annual deforestation in 2015 in terms of numbers of hectares. So there are some hotspots here, greater than 5 million hectare, parts of the Amazonia, and then various other levels of deforestation all over the world, especially in the global south, obviously something to keep in mind. On the other hand, if we look at satellite maps of change in forest area, so this is the net change in forest area, measures forest expansion either through afforestation or natural expansion minus deforestation. So there is some good news. China has afforested or naturally increased forest cover by more than 600,000 hectares. India is somewhere in the 200 to 400,000 range with various other countries, and there is still some negative numbers here, of course. As I mentioned before as well, this is largely new forest, whereas for India, the way calculations are done, I think this covers also greening, leaf area increase by agriculture, but this is forest expansion, so let's hope this is actually the net change in forest area itself. And as I mentioned also before, India has committed to producing new carbon source of 2.5 to 3 gigatons by its first NDC, the nationally determined contribution. So it has made extensive efforts to plant trees to increase forest area. There are some controversies with the conflicts between the government and the indigenous people who live in and around the forest and so on. Looking at drivers of tropical forest degradation, it gives a good sense as to where attention can be paid for protecting them, of course, or restoring them even. So livestock grazing on forest tends to be always a part of it. You are looking at total tropical, Asian, Latin American and African tropical forests. So wildfires consume a lot of them. They are mostly natural, but there are some vested interests who are setting fires as well. Deforestation or forest disturbance because of fuel wood and charcoal. More than 80% of people in sub-Saharan Africa, for example, do not have clean cooking fuels and rely on wood for fuel. So biomass burning for cooking is still incredibly high in number. Timber and logging, very high in Asia, very high overall as well, and Latin America and Africa doesn't seem to have that much timber probably left, or the forest cover is much smaller in any case. So that's the story, so we know where attention should go in some regions. The sad story here, again, to remind ourselves, the estimates and projections of tropical carbon sinks. When they are fully functional, they should take up over 6 gigatons of carbon per year. That's more than 10% of the total emissions at the current levels. The study's measurement-based estimates of carbon uptake in Amazonia and Africa are shown in red and blue here. So Africa in blue and Amazonia in red. Light blue and pink show projections from statistical models here out to 2040. So it seems like the peak carbon uptake was reached somewhere in the 1990s, and then we are headed in the wrong direction. They are losing their ability very fast to take up carbon because of warming, deforestation, forest degradation, and so on. So this is in megagrams of carbon per year per hectare. And that's obviously something of great concern, which we already mentioned. If tropical deforestation were a country, it would rank third in CO2 emissions. So China is up here, United States, and then comes tropical tree cover loss at 4 gigatons of CO2 equivalent per year. So we convert other gases like methane, N2O, and whatever else, greenhouse gases, into CO2 equivalent using the atomic masses and molecular weights. There is European Union, India, and Russia. So as a country, if it were a country, tree cover loss in the tropical forest would be the third in ranking. That's really bad news as well. And you can see here the time series going from 2001. There is a massive jump in 2015 to 17, 63% higher than average from prior 14 years. So that's of course coincided with the big El Nino of 2015-16, and I think 17 included the big Australian forest fire as well. Another news that's not so great here from the World Resource Institute: forests are capable of providing 23% of the cost-effective climate mitigation needed before 2030. So that's if forests were used as a part of the climate mitigation action, they would be 23% of the cost-effective measures. But despite this potential, forest accounts for less than 3% of climate mitigation funding. Maybe this is about to change if the idea of planting 1 trillion trees catches on and action actually begins to be taken. FAO is actively pushing mechanisms and mapping and restoring forest land. So it's called Forest Land Restoration, and they provide a restoration goal wheel like this with our topic land use in the middle, with many barriers to sustainability, of course. And there are components like this: food and products, climate, soil, water, energy, biodiversity, culture, and community. So under community, for example, there is positive outcomes in income, equity, health, and of course in food and products you have increased yield, market, finance. So forests take up carbon, but also enhance groundwater recharge, pest and mosquito controls, food, fiber, medicine, ecosystem services that are really in terms of biodiversity, culture, energy, and water, and so on, are immeasurable. The FAO Forest Land Restoration also worries about long-term sustainable financing. So it imagines national environmental funds that are additional to the budgetary allocations, climate finance, which is the mechanism under UNFCCC, development cooperation, private sectors, non-governmental funding, national budget and budgets and resources, non-traditional funding, for example, crowdfunding. So we have here national environmental funds that are extra budgetary, and then national budgets and resources that still have to worry about forest land restoration. Okay, people do have models for potential for restoration of forests, tropical forests. This is a model that's developed for lowlands, because the model doesn't work for mountain landscapes, but nonetheless, without going into details, it reports restoration benefits in terms of biodiversity, conservation, water security, climate change adaptation, mitigation combined. So it looks at the costs and benefits of forest land restoration in lowlands. Restoration feasibility: reduced land opportunity costs, reduced landscape variation in forest restoration success, and higher likelihood of forest persistence are combined in these calculations. So here is the scale going from 0 to 1 in terms of restoration opportunity score. Okay, so that's what is being plotted here. It's a model output, but nonetheless it's a good guidance in terms of how to recover above ground biomass with various benefits accounted for. In C, we are looking at benefits combined with feasibility of restoration. So higher scores, values ranging from 0 to 1, represent landscape with higher potential of potential restoration benefits and feasibility. Depiction of boundaries and geographic names is simply for display purposes and does not imply views regarding the legal status of any territory, so they didn't want to worry about international boundaries. Nonetheless, putting this all together, in theory 751 million acres of degraded land in the tropics could be restored to continuous intact forests. Using current and estimated commitments from Bonn Challenge and New York New Declaration on Forests, our model assumes that restoration could occur on 435 million acres. So this calculation and drawdown is separate from this paper that's reported here, but it also has similar calculations. Through natural regrowth, committed land could sequester 1.4 tons of carbon dioxide per acre annually, for a total of 61.2 gigatons of carbon dioxide by 2050. We can put that in the context of how much carbon has to be taken out, or where we have to be in terms of emissions and sequestration by 2050 for meeting any of our temperature targets, like 2 degrees with a 66% probability by 2100 and so on. Only carbon stored in soil organic matter and above ground biomass is accounted for. Below ground biomass is not included in these calculations, which of course is additional co-benefit of for tropical forest restoration and protection and reduced deforestation and degradation.